Today is a very important day. Today is the day that you stop hating fractions. Okay? I'm not saying that you're going to love them, but you're going to understand them. You're going to know how to work with them, and that'll let you deal with them rather than hating them. They will have no power over you. Let's start out by looking at what a fraction is. Okay? Say we have a pizza. And this pizza is cut into 8 pieces. The fraction describing the pizza is 8 over 8. We have 8 pieces to make the whole. And we have 8 pieces that we have. So if somebody comes along and eats a piece, then this becomes 7. We have 7/8 of a pizza left. Okay? Now someone comes along and eats another piece. So we have 6 pieces left. Okay? We know that we can take a 2 out of both the top and the bottom here and make it 3/4. Okay, what is that telling us? It's telling us now that it only takes 4 pieces to make a whole, and we have 3 of them. What we're doing when we change this bottom number is we are changing the size of the piece that we have. In this case, we're combining 2. When we divide this 8 by 2, we are combining them. When we divide this 6 by 2, we are seeing how many pieces are there now. Okay? Because we're combining 2 pieces, that means we have half the number of pieces. Whenever you change the bottom number, the top number will change. Okay, so we have 3/4 of this one. Now let's say we have a second pizza. This one's cut in 6 pieces, of which we have 5 of them. So how much pizza do we have total? We need to add them. 3/4 plus 5/6. Okay, the denominator here is kind of a unit. One of these pieces is not the same as one of these pieces. So we have to make them the same. You cannot add or subtract things of different units. For example, how much is 4 apples plus 3 ideas? 7 what? The question doesn't make sense because we're asking to add 2 very different things. Okay, so what we need to do is we need to find a common size and cut the pieces into that size so that we can add and subtract them. How we do that is we get the biggest number that we have here. We got 4 and 6, so 6 is the biggest number. And we count by 6s until a 4 fits in there evenly. 6. Nope. 12. 4 will go into 12. So our common denominator is 12. Okay? You can multiply the 2 together, and that will always work, but it'll give you bigger numbers than you need. In this case, it would have given us 24. And we really don't want to work with any bigger numbers than we have to, right? Okay, to get 4 to 12, we have to multiply it by 3. Remember what we do to the bottom, we have to do to the top. So we have 9. What we're doing here is we're cutting each of these 4 pieces into 3. I said 4 pieces, I meant 3 pieces. So now we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. 6 to get to 12, we need to multiply by 2. So we multiply 5 by 2. We get 10. What we're doing here is we're cutting each of these pieces into in half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 pieces. So now we can add, because these pieces and these pieces are the same size. They're the same thing. So we get 19 12s. This is what we call an improper fraction. Okay, it's because the top number is bigger than the smaller number. What that means is we have more than 1. So what we can do is we can take 2 of these pieces and stick them on the same plate as this one. So now we have 1 whole and 7 left over, okay? Which is, if we take this 19 pieces and we subtract 12 from it, we get a whole. We have 12 12s plus 7 12s. And that equals 1 and 7 12s. Which we can see here. We have the 1, the ones we moved, and 7 12s. Half plus 1 more. Okay? So this is how we add and subtract fractions. We have to make them, we have to find a common denominator, which gives us the same size piece, and then we do our adding and subtracting. Once we find the common denominator, we do not change the denominator. Okay? Let's look at some examples. Okay, once again, I'm using the Word Problems book. F1 number 4. In order to complete a job, Mrs. Drano needs the following lengths of pipe. 18 and 5/8. Centimeters, 10 and a half centimeters, and 32 and 3/4 centimeters. What is the total amount of pipe she needs? Okay, we treat this like we did when we were doing the conversions. We separate the wholes from the fractions. Okay? We can add these right away, 50, so and we get 60. 2 and 8 is 10, and then 1, 2, 5 plus the carried 1 is 6. So now we just have to add these 3 numbers. All right? 5/8 plus 1/2 plus 3/4. We look at the number with the highest value in the denominator. It's 8. And we say, can the other numbers fit into 8 evenly? And the answer is yes. To do it, we have to multiply the 4 times 2 on the 2 times 4. Okay? So let's see what that gives us. 5/8 plus 4/8 plus 6/8, which gives us 4 and 6 is 10 plus 5 is 15. 15/8. 15 is bigger than 8, so it's an improper fraction, and we need to simplify it. Okay, that gives us 8/8 plus 7/8, which is 1 7/8. We now need to add that to this. So we get 61 7/8 as our answer. Let's look at another problem. F1, number 5. Mel's Market had 82.5 pounds of apples. If 4 3/4 were spoiled, how many pounds of good apples were left for Mel to sell? So we had 82.5, and we're subtracting off 4 3/4. All right. We have a problem here. A half is smaller than 3/4. So what do we do? Well, if you remember back to when we talked about measurements, you have to borrow. You have to take one of the big thing and cut it into the smaller ones. Okay? So we're going to change this 82 to 81. And we're going to take that extra 1. And we're going to cut it in half. And there's 2 of them there. Okay? So we got 82 apples, 82 pounds of apples, okay, whatever. We take one of them, we cut it in half, and we combine it with that other half, this half, and we get 3 halves. 2 from the one we cut and 1 that was already there, so it's 3. And the unit is half a pound of apples. So we've got 81 3/2 minus 4 3/4. Now we can do that one. Okay? 81 minus 4 is 77. Now let's look at the fraction part. 3/2 minus 3/4. We need the same common denominator, which is 4, because 2 will go into 4. But we have to multiply each of these by 2. Okay, 3 times 2 is 6. 6/4 minus 3/4 is 3/4. So our answer is 77 3/4. All right, let's look at another one. F1 number 3. Fred had a piece of lumber 16 feet long. 16 feet. He cut pieces that measured 4 3/4 feet, 5 1/4 feet, 1/2, and 4 5/6. Okay, and they want to know how much is left. So we're going to add all of these up, and we're going to subtract it from 16. Okay? Now remember what we did when we were doing measurements? We would look to see if we could put tens together, or whatever it takes to make a whole. We do that here too. Okay? 3/4 and 1/4, 3/4 and 1/4 makes 4/4. Right? 3 plus 1 is 4. So that makes a whole. So now we're only adding 1/2 and 5/6. Okay, the common denominator is 6 because 2 will go into 6. Well, we got to multiply by 3. 3/6 plus 5/6 is 8/6, which is 6/6 plus 2/6. 6/6 becomes 1. 2/6 is 1/3. All right? So we need to add 1 1/3 to whatever we have for the whole numbers. Let's look at the whole numbers. Okay, that's 10 and 4 left over, so 14. So the total pieces are 15 1/3 feet. Now we want to subtract this from 16. So 16 minus 15 and 1/3. Okay, what do we do here? There's no fractions. All right? We want to take 1 foot off of this, and we need to cut it into thirds. Why thirds? Because this is a third. So we want to cut it into the same size pieces as we already have, so that way we don't have to find a common denominator and do all the multiplication and stuff there. So we're going to change the 16 to 15 and 3/3. 15 minus 15 is 0. 3/3 minus 1/3 is 2/3. So he has 2/3 of a foot left from his board. F1 number 8. If Mrs. Baker had 1½ dozen eggs, and she used 2/3 of a dozen to make scrambled eggs for breakfast, how many eggs are left? So we have 1½ minus 2/3. All right, we know that 2/3 is bigger than 1/2. So we need to cut this 1 into 2 halves. And that gives us 3 halves minus 2/3. All right, we need a common denominator. We get the largest denominator, which is 3. We count by 3s. So 2 doesn't go into 3, but 2 does go into 6. So we're multiplying by 3 on this fraction and 2 on this one. So we get 9/6 minus 4/6. So we have 5/6. We have 5/6 of a dozen. We'll just take this one step further and do the conversion. How many eggs does she have left? Well, there are 12 eggs in a dozen. So 5/6 of them. That means for every 6 there's 5 there. So there's only 1 missing for each half dozen. So we're only missing 2 eggs out of our carton that has a dozen in it. So that means we have 10 eggs left. Okay, that conversion was actually applying a fraction to something, which is multiplication. When we multiply, there are 2 situations that we multiply in. First one is when we have a whole and you're taking a part of it. Okay? So, for example, we were looking at pizza before. If you have a pizza and your friends eat 2/3 of it, they've eaten that amount. That is multiplying 2/3 times 1. So now let's see if you have 2 pizzas. And your friends eat 2/3 of each of these. What? Okay, this is literally 2 times 2/3. So 2, and we took 2/3 of each one. So now we can move one of these thirds over to this one. And we have 1 1/3 left. So now that we've done it graphically, let's do it mathematically. So 2, that's 2 over 1, because it's a whole pizza and there are 2 of them. And we're going to multiply it times 2/3. When we're multiplying fractions, we put everything in fraction form. Even if it's an improper fraction, especially if it's an improper fraction. Okay? And then we just multiply straight across. Okay? When we multiply straight across, we get 2 times 2 is 4. 1 times 3 is 3. That gives us 4/3, which we can see 1, 2, 3, 4, which we can split into 3/3 to make a 1 and 1/3, and we get 1 and 1/3, which is what we did when we did it graphically as well. Let's look at an example of taking a fraction of something. F1 number 9. Val ran 1 mile, which is 5,280 feet. 5,280. Judy ran 3/4 of a mile. How many feet did Judy run? So we want to take 3/4 of 5,280. So 5,280 over 1 times 3/4. We can just multiply straight across. However, that's going to give us bigger numbers than I want to deal with. So what I'm going to do is I'm going to cancel some. Okay, I can see that both 5,280 and 4 are even numbers. Let's look at why I can cancel crosswise like that. Okay, first of all, there's no equal sign between it. That's your key thing. If there's an equal sign between it, like you have in ratios, you cannot go crosswise. However, since we're multiplying straight across, what we're getting is that. Okay, you may say, hey, that's in a different order than it was over here. You are 100% correct, but you know what? It doesn't matter, because 3 times 4 is the same as 4 times 3. We can rearrange them, and it doesn't matter. All right, so let's take 2 out of both the top and the bottom. That gives us 2 left down here. Okay, remember we talked about dividing odd numbers? Okay, so we have 5 divided by 2, that's 4 divided by 2, which is 2. 12, 6, 4, 0. Okay? So it's still even. So we can take the other 2 out. One, 3, 2, 0. But now our denominator is 1, which means we just multiply these 2 together, and that's our answer. 1, 320 times 3, 6, 9, 3. So our answer is 3,960 feet. All right, let's do another one. F1 number 1. Corporal Drudge earns $9,720 a year. If 1/5 of his earnings go to taxes, how much did he pay in taxes? So we want to know what 1/5 of this is. Okay? So we're just multiplying straight across, but since both the numbers are multiplied by 1, we just end up dividing 9,720 by 5. Now remember, the secret with dividing by 5 is you double it and move the decimal. Okay, you can also move the decimal and then double it. So we're going to move the decimal there. So we got 972 times 2, 4, 14, 18, 19. There we go. So he paid $1,944 in taxes. So far, we've taken a fraction of something that's whole. However, the rules stay the same if you're taking a fraction of a fraction. For example, F1 number 6, obese, has 16 pounds of candy. If he eats 4/5 of it, What part of a pound does he eat? Okay? How do you know that this is multiplication and not subtraction? The answer is in the units, okay? When we were subtracting the eggs, we subtracted 2/3 of a dozen from 1.5 dozen. They both had the same units. They have to when you're adding and subtracting. Okay? In this case, he eats 4/5 of it. Okay? Not 4/5 of a pound, 4/5 of it. That of tells us that we're multiplying. And the fact that that 4/5 doesn't have a unit on it. Okay? So, we have 15/16 pounds of candy. And he's eating 4/5 of it. So we are taking a fraction of something. Okay? We're going to cancel here. This 5 and this 15 leaves us 3. This 4 and this 16 gives us 4 there. So we got 1 here and 1 here. So we're multiplying 3 times 1 and 4 times 1. And we get 3/4. This is 3/4 of a pound. Okay, because it is of it. So this has pounds as a unit, and this doesn't have units. So the pounds comes through. Okay, the other time we have multiplication of fractions is when we have something with a fractional unit and we're making multiple copies of it. All right, let's look at a problem. The supply clerk ordered 120 cans of green paint. If each can weighs 5¼ pounds, how much will 120 cans weigh? Okay, so we're multiplying 120 by 5.5, by 5¼ I like to split these. $120 times 5 is 600. All right, sometimes you just need to get this far and you can figure out which answer it is. And this is one of those cases. Our choices are 630 pounds, 1080 pounds, 540 pounds, and 600 pounds. So, you know it's not the 1080, that's way too big. Okay? You know it's not the 540, because that's less than the 600. And you know it's not the 600 because you're going to be adding something to it. So it's got to be the 630. Let's actually do the rest of the problem and show that. Okay, 120 times 1/4. We can take a 4 out of both of this because we got a 12 here, right? So we got 30 here. 30 times 1 is 30. 1 times 1 is 1, so we have 30. We add that 30 to the 600, and we get 630. Let's do another one. F1 number 11. The wooden handle of a mop is 3 3/4 feet long. How many feet of wood is required to make 2,000 mops? Okay. You can kind of actually see this one. Here's a mop. You know, mop, another mop, another mop, another mop, another mop, 2,000 times. Okay, so that is multiplication. I'm going to split this one. 2,000 times 3. Okay, 3 times 2 is 6, so we have 6,000. Now we have 2,000 times 3/4. That's a 4. 2,000 over 1 times 3 over 4. I see a 20. I know 4 can go into 20. Okay, so we have 500 times 3. That's 1,500. We need to add that to the 6,000. And we get 7,500 feet. In this case, it was necessary to do the whole steps because the answers were 8,000, 7,800, 7,500, and 6,750. So knowing that we were looking at 6,000 to start with, that could have been any of them, okay? So we had to do the whole thing. Let's do one more multiplication problem of this type. F2, number 5. A box of crispy crackers weighs 3/4 of a pound. They're packaged in boxes of 30 to a carton. How much does a carton weigh? Okay, so we've got 3/4 and 3/4 and 3/4 and 3/4, 30 times. Okay? In this case, we don't need to split it up because we've got only the fraction part. So we have 30 over 1 times 3 over 4. Okay? I'm going to take a 2 out of each of these. Okay, now I got 15, 3, and 2. All right. I can't take a 2 out of either of those, and I can't take a 3 out of what's here, so we got to work through it. We got 45 over 2. All right, so we need to split that up. 4 divided by 2 is 2. 5 divided by 2 is 2.5. So 22.5 pounds is our answer. If Matt Theriault used 3 1/8 yards of cloth to make a pair of slacks, how many yards will Matt need to make 4 pair? Okay, so we use 3 1/8. And he's making 4 pair, so we're multiplying by 4. 3 times 4 is 12. And now we need to have 1/8 times 4. 1/8 times 4 over 1. We can take a 4 out of each of these. 8 divided by 4 is 2, so we have 1/2. So it's 12.5 yards. In some of the last problems I've done, I've split the mixed number in half into the whole part and the fractional part. Let me show you why I can do that and when you can do that. Okay, first of all, a mixed number, say 1 3/4, is literally 1 plus 3/4. When we're multiplying, there's a rule that says A times B plus C equals AB plus AC. This is what I'm using when I'm multiplying a mixed number times a whole number. For example, if we multiply this 1 3/4 by 5, this is what we get. 5 times 1 plus 5 times 3/4. Okay? multiply by the 5 times the 1 and the 5 times the 3/4, and we get 15 quarters. We simplify that, change it to a mixed number, and then we add them. We get 8 3/4. You can only use this when you're multiplying a mixed number times a whole number. Because if you multiply a mixed number times a mixed number, for example, 5.5, what you've got is 1 3/4 times 5 plus 1/2. So you have to do that whole FOIL thing to do it this way. So you have 5 times 1 plus 5 times 3/4 plus 1 times 1/2 plus 3/4 times 1/2. Well, that's a lot of work, so we don't do it that way. When we have a mixed number times a mixed number, we change them both into improper fractions. That's when the top number is bigger than the smaller number. In this case, 5.5 would be 5 times 2 is 10 plus 1 is 11. So 11 halves times 4 times 1 is 4 plus 3 is 7. 7/4. So we get 77/8. And then from there, we can simplify it. Okay? That's going to be 9, because 9 times 8 is 72. So 9, and we have 5 left over. 9 and 5/8. Okay, we could get the same thing if we spread that out like that, but that's more work than we want to do. So in this case, the standard way of just changing everything into fractions and multiplying works the best. This is something you can do with multiplying, but it doesn't really work well with division. So stick with splitting it up like I did, with multiplying a whole number times a mixed number, or a whole number times a fraction, and leave the mixed numbers in the standard method. Okay, now let's talk about division. Okay, division is just multiplication, but backwards. Let's look. All right, we talked about how if we take a whole and we multiply it by a fraction, we get a part. Let's look at that. We have 8 dots. The fraction is 3/4. We take 3/4 of those dots. How many dots do we have in here? 1, 2, 3, 4, 5, 6. We have 6 as our part. So, whole times fraction equals part. But what if we have the part and the fraction and we want the whole? So we divide both sides by fraction. Okay? So the part divided by the fraction is the whole. So let's look at what's going on here. We have 3/4. And we have 6 dots. We're looking for the whole. We're looking for how many there are in total. So how do we go about that? Well, first thing we do is we go, okay, we're missing one of these parts. So let's find out how many dots are in one part, right? Okay, we divide the 6 by 3 to get how many are in one spot. Okay? So there is 2 in one spot. So what we did is we divided by 3. Now, since this is only one that's missing, we can just add those in. However, if it's just some random number that are missing, we're going to need to divide by the number of pieces we have to get how much is in one piece, and then multiply by how many pieces it makes to get a whole. In this case, 4. So we need to take our part and multiply it by 4/3, which is just this fraction here turned upside down. We call this inverting and multiplying. Perhaps you've heard of it before. So 6/1, 4/3. We cancel this, we get a 2. Here's our 2 dots. Now we're multiplying 2 times 4 because we want 4 wholes. And that gives us our whole back, our 8. So when we're dividing, we just take the fraction that we're dividing by, flip it upside down, and then multiply across. Let's see some examples. Just like with multiplication, there's 2 cases that we use for division. First is when we're finding that whole. The second, which is more common, is when we have something that we are splitting into fractional pieces. Let's look at some examples. F1, number 2. Polyester bought 6 1/4 yards for $50. How much did the material cost per yard? Okay, there's the key. Cost per yard. Cost per yard. There it is, division. Money on the top, yards on the bottom. We have $50 and 6 1/4 yards. So we're dividing 50 by 6 1/4. All right? We can't do it the way it sits. All right? We've got 50/1, and we have to turn this upside down. Well, you can't turn it upside down if it's a weird number like this. All right? So we need to make this an improper fraction. We do that by taking all 6 of these yards and cutting them into 4 pieces so that we can add it to this piece. 6 times 4 is 24, plus the 1 is 25. Okay, you can always multiply the whole number times the denominator, and then you add the numerator. So we have 6 1/4 is 25/4. Now we're going to invert that. We're going to turn it upside down. Now we can cancel. 25 goes into 50 twice. So now we have 2 times 4 is 8/1. So material costs $8 a yard. F2 number 1. Bedazzle Dress Company needs, on the average, 3.5 yards of cloth to make a dress. How many dresses can be made from a 70-yard bolt of cloth? So we're going to be dividing 70 by 3.5. So we need to change this to an improper fraction. 3 times 2 is 6, plus 1 is 7. So we have 7 halves that we're dividing by. 70/1 times 7 halves, and we flip it, 2 7s. So we can cancel the 7s. That makes us a 10. So 10 times 2 is 20. They can make 20 dresses. F2 number 8. Antipasto cooked 8.5 ounces of spaghetti for 3 people. How many ounces of spaghetti was this per person? So we're dividing 8.5 by 3. Okay, this 3 is 3 over 1. So we have to make this an improper fraction now. 2 times 8 is 16, plus 1 is 17. Now we're going to take this and we've got to flip it. There's nothing we can cancel there. That 17 is a prime number. We can just multiply through 17 over 6. Now we need to break this up. We need to make it a proper fraction. So we take out a 6. And that gives us 11/6. So we take out another 6. And that gives us 5/6. Okay? So, two and 5/6 ounces of spaghetti per person. The number of problems that give you a part and a fraction and ask for the whole are not that common. Here's an example of one. F3 number 1. Cuisine agreed to make baklava for a banquet. Each day he bakes 2/5 of the total. How many days will it take to prepare for the banquet? So we're looking for the whole, the time it takes to do the whole job. The part we're given is 1 day. So the part equals 1 day. The fraction is 2/5. So 1 divided by 2/5 is 1 over 1. We're going to flip that, 5 over 2. 5/2, which is 2/2 plus 2/2 plus 1/2, or 2.5 days. All right, if you want to see this graphically, okay, here is the whole job. You can do 2/5 at a time, so let's divide this into 5 pieces, okay? Pretend these are equal sized. Okay, this is day 1 a.m., day 1 p.m., day 2 a.m., day 2 p.m. There's our 2 days. And then we have day 3 a.m. That's an M. So we only have half of that third day. So we have 2.5 days. Let's do one final problem that combines adding and division. F1 number 12. 3 children weigh 51.5 pounds. 43 3/4 pounds. And 38 1/4 pound. What is the average weight of the children? So we need to add those 3 numbers and then divide by 3. All right? First thing I do is I say, hey, 1/3 and 1/4 make a whole. Which means that we can just bring this 1/2 down and not have to add any other fractions. So now we add this part. 8 and 2 is 10, and we have 3 left over. 5, 4, and 1 is 10. We have 3 there. So 133.5. 133.5 divided by 3. Okay? 2 ways to do this. We can do it the standard way, which is multiply the 133 by 2 and add the 1, which gives you 267. And then invert the 3 over 1. and multiply. That looks kind of ugly to me. So I'm going to split this up. Okay, I'm going to split it up. So I'm going to pull out as many 3's as I can out of this 133. Okay? So I know 132 is the same as 120 and 12. Okay? And if I'm pulling a 3 out of each of these, that gives me 44. All right, if I take a 132 out, that leaves me 1.5 left over. So 1.5, when we put it into, make it an improper fraction, we multiply 2 times 1 and get 2 and add 1. So we get 3 halves. And we invert and multiply. You cancel the 3's and get 1/2 as our answer. So our answer is 44 1/2. I hope that you found this lecture, I won't say enjoyable, but informative. And that fractions no longer hold any threat to you. I'll see you tomorrow when we're talking about decimals.